So we're on a field trip here today with TRA Snow and Sun. We're at the Montessori School in Salt Lake City. This is a private school. Earlier this year, we were asked to design a custom 15-degree ballast system for intermountain wind and solar. The customer chose that 15-degree angle, and they wanted a system that would not penetrate the roof so as to reduce any chance of leaking. And custom to this location, which has about a 43 pound per square foot snow load, as well as a 90 mile per hour wind speed. So Intermountain Wind and Solar installed 125 Solar World 265 watt panels here. That's a total of 33.1 kilowatts on the ballasted portion of the roof. So the lowest part of the system is the ballast tray. The ballast tray continues all the way down on a row. It's spaced appropriately to fit the ballast blocks. The ballast blocks provide the weight needed to hold the system down to prevent the wind from blowing it off. That's the ballast tray. Then the next part you can see here is the frame. There's a low section of the frame here, and you'll follow along to the high section of the frame here. The low section is for the front of the panel, and the high section is where the top of the panel rests. The other parts would be, you can see here, this is a platform. The platform allows the panel to rest on something, and this bolt along with this clamp fixes the panel to the frame, and that's the basics of the system. So another thing about the system being 15 degrees, we at TRA Snow and Sun had to make sure there was enough separation between the arrays so as the shadow line at the winter solstice does not cast or shade onto the other system, onto the other row. So this angle, this width, and this angle right here has been determined appropriately based on that 15-degree angle. Another benefit to our system is because it's so far elevated off the deck, we can go right over the top of roof penetrations like the one that you can see here. Another benefit to our system being elevated is it allows the snow to shed off the panels and collect on the ground, so the panel can be more efficient in the wintertime of collecting that solar power. When we start and stop an array of panels, we have to use half of a frame. You can see the high portion right here, which supports the top of the frame, and the low portion of the frame, the half low portion of the frame here. Most of the other frames are a full frame, which start at the high point, work their way underneath the ballast tray, and wrap back around to support the front of the panel on the other side.